Hi, on the workbench today I have another battery-powered spot welder for review. This one is a DOCREATE TK-10A, or DOCREATE. I'm not sure what exactly the right pronunciation is. Anyway, it was sent in from Banggood. As usual, I will leave a product link in the video description below for those who are interested in getting one after watching this video. Now, on this channel, I have reviewed quite a few of these battery-powered spot welders by now. I will leave a few links to those reviews below in case you wanted to do some comparisons yourself. Most of these battery-powered spot welders on the market work pretty much the same way. Most rely on the low internal resistance of the built-in LiPo batteries so that they can generate the high current required for the welds. Of course, the internal power MOSFETs control the duration of the weld pulses, and you can fine-tune depending on the task at hand. Of course, there are also supercapacitor-based spot welders, but they tend to be more expensive. The principle of operation, though, is fairly similar nevertheless. Alright, let's power it up and we'll check out some of the settings. But first, of course, let's remove the screen protector here. And I think we want to stand it up so we can see it better. Okay, so the power button is on the top. Let's power it up. Oh man, the sound is a little bit scratchy. So the first thing you probably will notice is that the voltage displayed here, you can see here, is right around 8 volts. This tells me that the TK-10A uses 2 groups of LiPo batteries in series. I'm not exactly sure how many batteries are there in total. It could be 2, it could be 4. It all depends on the design and configuration. We should be able to verify that during our teardown a little bit later. This actually stands out from all the other battery-powered spot welders I had reviewed before, as all the other ones are powered by a single group of LiPo batteries, meaning the output voltage is around 4 volts. Now, I think by doubling the voltage, the performance of this welder should be superior. The reason I'm saying that is because these welders are advertised to be able to deliver over 1200 amps peak current. This means if you were only using 4 volts, the internal resistance of the switching MOSFETs and the wiring and the nickel strip, all of these resistance add up, would need to be as low as 3 milliohms. This is highly unlikely. But if you double the output voltage, it became more plausible, as now instead of 3 milliohms, we are allowing 60 milliohms here in order to achieve the 1200 amps peak current. Although still pretty difficult, it is not as far-fetched as before. And by the way, now I just remembered, the overall design of this TK-10A is actually pretty similar to that of the Finersi SWM10 I reviewed a while ago. Let me actually bring that one here for a quick visual comparison. Yeah, this case and the design are pretty much the same. Of course, the button layouts and output locations are slightly different, but they are fairly similar. Of course, the SWM10 only has a single LiPo cell, so the output voltage essentially is half of what we have on the TK-10. As you can see here, the output voltage is 3.9 volts. Now I wonder if these spot welders were from the same manufacturer. You can see even the language used here are identical. Portable, intelligent, color screen spot welding machine. And you can see here, they are exactly the same. Anyway, back to the TK-10A. The user interface here is actually quite intuitive. You can use the button here to cycle through different settings here. You can see. And this parameter currently is highlighted. That's the delay. And I assume that's the time delay before welding after both leads had made contact with the nickel strip. Of course, you can select that. Right now it's 0.7 seconds. You can change it to 0.8 and go down all the way. Let's see. The lowest is 0.5 and the highest, it looks like we can go quite a bit. Yep, the highest is 2 seconds. So let's go back to 0.5 seconds. And I think that's actually 0.7 seconds. That's actually the out-of-box setting. And what else? Let's go up. And the next one is preheat. Not sure if you can read that. It's 3 milliseconds. And I assume that controls the width of the preheat pulse. And what else? Let's move up here. And gap right now is set at 5 milliseconds. I'm guessing that's the time between the preheat pulse and the main pulse. And next, gear. This controls the main pulse, I guess. Of course, instead of using the time as a unit, it is a number. And let's see here. If I go down, it goes all the way down to 1. And if I go up, it goes all the way up to 99. That makes sense. It's between essentially the power of 0% and 100%. So let me adjust it down a little bit so that we don't forget. Anyway, so the next one, that's the protection, I guess that is essentially used to detect short. The protection is by default off. We can turn it on, of course, on and off. And the next setting, of course, we go to mode, but we'll skip that for a minute. And let's actually go to the times. Now, this controls how many times the main welding pulse is generated. So by default, you can see it says 1. And of course, we can change it to 2. Can we change it to 3? Nope. So by the look of it, you can either do it once or twice. So that's the times. Now let's actually go back to the mode. And we can go in here. I assume I just need to long press it. Yep, you can see here. Now we're in the mode menu. Let's just briefly take a look at what options we have here. We can change the language. We can change the buzzer on or off. Let's leave it on. And brightness, we're already at 100%. And direction, I assume this is the display. Yep, you can see, whoa, you can use it upside down, I guess. That's the display direction. And auto sleep. The current limit right now is set at 1250 amps. Can we change that? Wow, looks like we can change it all the way up to it's 3000 amps. I'm not sure how does it limit that, but apparently you can change it all the way up to 3000 amps. Let's actually go down a little bit. Let's do 1000 amps. So that presumably is because we have a much higher voltage, and now we can go much higher. So let's leave it at 1500 amps for now. And we can change the temperature alarm setting. Device info, let's go in and take a look. So here you go. That's the version 1.1. And default, which resets everything to factory default, and return. Okay, that's pretty much all the settings you can play with on this TK-10A. You can also use this welder as a power bank, as we have a USB output, but I would caution against doing that, as the welder relies on the low internal resistance of the LiPo battery. As the battery ages, the internal resistance would increase. So the more you use it, the faster the battery would degrade. And when the internal resistance of the battery gets to a certain point, it won't be able to generate sufficient current for welding anymore. That said, it's good to know that you can use it as a power bank in emergency situations. Let me actually plug in the leads. And by the way, let me first show you. Here are the leads supplied. You can see that they're actually a pretty good quality one. If you read, we have 8-gauge wires here. So these are actually thicker than some of the other ones I have reviewed before. And now you can see the quality of the leads are actually pretty good. Now, in the package, you also, by the way, let me show you the package here. You have, of course, a manual. Here we have a USB charging cable. And here we also have a few guides for building battery banks. And we have a file, and we also have a couple spare tips and some nickel strips. That's actually everything came with a spot welder. I just quickly compared the leads with some of the other spot welders I have. Unfortunately, I don't think they're all the same size. Let's, for example, take a measurement here. So these are the leads that came with this TK-10A. And let's take a look. You can see that it's roughly 5.9 millimeters. And here's the one came with the Fernersi SWM10. You can see that this is significantly smaller. And here is another one from another welder. And this one, you can see that it's significantly thicker. So I'm not sure why different spot welders use different sized connectors. They're not standard at all. Anyway, let me plug these in. Before we proceed to testing the welder, let's actually take a look at the welding waveform. For that, I'm going to discharge through a 10 ohm resistor, and we'll use the single shot mode to capture the welding pulses. All right, let's give it a go. The setup here is a little bit clumsy, so we may need a few tries. Yeah, you can see we captured a welding pulse, so let's do some analysis. So the first pulse, that's the preheat pulse, and you can see here we set it as 3 milliseconds. And indeed, we're measuring roughly 3 milliseconds, so that's actually very good. As you remember on some of the other welders, the pulse settings are actually not very precise. So let's actually take a look at the spacing here. And it looks like the spacing is around 5 milliseconds. And let's see what we have here. Yep, you can see here the gap, that's 5 milliseconds. So far you can see is pretty accurate. And you can see here the preheat pulse is 3 milliseconds, the gap is 5 milliseconds, and of course the gear that controls how long the actual main pulse is. So right now at 74%, let's see what that is. So that, let's zoom out. 74%, 75 roughly. We have about 27 milliseconds. So let's actually change that to, let's say, 100%. And let's take a look. And we'll do another single shot. So all the other conditions are the same. And you can see I actually didn't change the marker here, so that main pulse is actually roughly 25% wider. Very good. So now let's actually change the preheat pulse width and also the width between the main pulse and the preheat pulse and see if the settings are accurate here. So let's come back here and I'm just going to change, let's see, the preheat instead of 3 milliseconds, let's change it to 5 milliseconds. And the gap, instead of 5 milliseconds, let's change it to 10 milliseconds, and that would be a good test. So if this measurement turned out to be accurate, then we can assume the settings are pretty much accurate across the range. And one last thing, I want to change the main pulse width from 99% to 50%. Let's do that. So let's actually take a look at the full width, what that is. So the full width is roughly 25 milliseconds. So half of that should be right around 12.5 milliseconds. So let's test that out. All right, let's first measure the preheated pulse. And now that's roughly 5 milliseconds. Yep, we changed that to 5 milliseconds. Very good. And the delay here, we changed it to 10 milliseconds. And that's roughly 10 milliseconds. And the main pulse here, that should be around 25. So the main pulse here is 13 milliseconds. And I thought it should be 25 milliseconds. Maybe I remember something wrong. Let's actually take a look at the full strength here. So if I go back to 100, and let's do that again. Actually, we got it right, because right now is the full width. That's actually 25 milliseconds. So perfect. So the timing of the pulses on this TK-10A is spot on. Now let's actually take a look at the two pulses. So for that, I think I need to zoom out the time scale all the way, because the two pulses are fairly far spaced. So let's do that. And that should be good. Yeah, you can see now we captured the two pulses, actually. And these are two sets. You can see that we only have one preheating pulse, and then we have two main pulses. And let's see the interval between the two main pulses here. And that's around 500 milliseconds. So of course, the limitation is that we can only do two pulses. For example, if I come back here, and I change it to 1, and then I expect we only hear one beep. And indeed, you can see that this is actually a single pulse. Originally, we had another pulse right here, but right now we change it to one pulse. You can see that we only have this single pulse here. We have a preheat pulse and then the main pulse. I totally forgot to mention earlier, there is also smart modes built in. And you can see here, we can change what object you are trying to weld and what type of material it is, whether or not, for example, here it's nickel plated or pure nickel, and so on and so forth. And I assume actually these are just different settings to fine tune the pulse width and also the pulse strength. And that's something you can already control, but that's good to know that they actually have experimented and provided these as options. So that's excellent. So now I change the gear to 50, so that's half the power. I have the cells here in the brackets, and let's zoom it in and we'll take a look. So that's 2 pulses. And let's do another one. And looks like it's actually pretty well. You can see we have the welds very securely welded. And if I try to remove it, and you can see actually the strip is torn. We'll have this holes. So clearly it is welded onto the battery with no problem. Very good. So it looks like this setting is already pretty good. And yes, you do have the ability to select preset modes, but I think those are probably just bells and whistles you don't really need. As you can see here, we simply just set it to 50%, and the result is actually fairly good. Very good. So let's actually finish this weld. I didn't bother cleaning it. Now I have a fresh piece of nickel strip. And you can see it actually welded very well. All right, so let's do the other side. And you can see that this is actually a very good weld. Just for curiosity, I turned the gear all the way up to 99. So this is the most powerful weld. And let's take a look at what it does to the nickel strip here. Whoa, that was not expected. But anyway, so that's actually quite powerful. And you can see that that's 99. Definitely, you probably don't need that. So I'm glad I didn't start with 99. Let's go back to, let's say 10, and see if we can do anything with that. Yeah, even 10, you can see we are able to weld the 2 pieces together. And you see the big hole here, that's the 100%. Clearly that power setting is probably for much stronger material, not for this thin nickel strip. So the weld on that nickel strip with 100% power is actually quite spectacular. Now I'm actually thinking if we can actually weld these 2 blades together. These are stainless steel, I believe, and these are quite thick. So let's actually take a look. I don't know. Let's give it a try. And you know what? Wow, we actually are able to weld these 2 stainless steel pieces together. And this is actually really powerful. And I'm actually surprised. Let's try it again. Let's zoom in. And you can clearly see that these 2 are welded together. So I'm actually very impressed with the performance of this welder. All right, now I think it's time for us to open it up and take a look inside. Now I think the screws might be hiding under these rubber feet, and unfortunately we'll have to remove this rubber strip. Let's actually take a look. Yep, you see that the screws are hidden inside indeed. And let's see the rubber feet. Alright, I don't think I'm going to disassemble it any further because we have these high energy cells, and if you accidentally short these, it's going to be disastrous. But anyway, you can see we have actually 4 of these pouch cells, and they're in 2 groups. You can clearly see 2 at the bottom, 2 on the top. So this essentially forms the 7.4 volts nominal welding voltage. And you can see each of the cell is 4 amp hour. So altogether, essentially we have a 7.2 volt 8 amp hour battery. The main switching device are these NEC 30H290 MOSFETs. These are in parallel. Actually, altogether, we have 6 of them. 3 on top and 3 I'll show you here. And you can see, not sure if you can see through, but maybe this side. Yeah, you can see we have 3 of those in there. So altogether, we have 6 of these. If you look at the datasheet, each one has a maximum drain current rating of 290 amps and an on resistance of 1.8 milliohms. So I do think that 6 of these in parallel are capable of passing 1200 amps, and perhaps much higher, as the highest rating current I think is close to 3000 amps. And the configuration here does support that. Overall, I think the construction is actually quite decent. Of course, we have this 2-board design. As I said, I'm not going to take it out because I don't want the remote possibility of shorting these batteries. But you do have the display board on the bottom and perhaps a microcontroller on top of that board as well. As you can see here, everything looks pretty neatly assembled. I have to say, it must be nerve-wracking for the workers to assemble this device, and you need to be very careful when soldering these batteries onto the board, as there's no protection, and one wrong move could cause a disaster. Anyway, that's all I wanted to cover in this video. I hope you enjoyed the review. If you liked the video, please remember to give it a big thumbs up, and don't forget to subscribe to this channel for more videos like this in the future. Your participation makes videos like this possible. Thanks for watching, and I will see you next time.